Have you ever given it any thought, whether we're genuinely alone in the universe, or, on the other hand, if there's something else to our reality besides what we see? An instance in which the James Webb Telescope at last demonstrates that we live inside a black hole. Go along with us as we find out more about this noteworthy news that will make you think twice about everything you thought you knew about the universe. So, exactly what are black holes? They're like something out of a bad dream. Sure, you might have seen them in science fiction movies, but in reality, they are considerably more terrifying. They're not just that, as indicated by researchers, black holes in space are, in fact, gigantic volumes of matter compressed into an extraordinarily small region. Consider a star that is multiple times larger than the Sun, all packed into a sphere the size of New York City. The gravitational pull is so intense that nothing, not even light, can escape from it. Researchers have been captivated by black holes for a long time. Since then, they've studied objects in space so massive and dense that they could trap light. The most famous ideas about black holes were predicted by Einstein's theory of general relativity. Basically, when a huge star dies, it leaves behind a small, dense core. If the mass of this core is multiple times that of the Sun, gravity dominates everything else, resulting in the formation of a black hole. It is not easy to identify black holes because they do not produce light. However, researchers have found ways to infer their presence by observing their impact on surrounding matter. For instance, if a black hole passes through a cloud of interstellar matter, it will pull that matter toward it in a process called accretion. Furthermore, when a normal star gets too close to a black hole, it can be torn apart, emitting X-rays. Black holes also have a huge effect on their surroundings. They can consume nearby stars, emit strong gas explosions, and even impact the formation of new stars in some regions while slowing it down in others. But where do black holes come from? Picture stars, once grand and bursting with energy, meeting their extreme downfall in a staggering explosion called a supernova. The vast majority of black holes are born from massive stars that have reached their divine retirement party in a supernova explosion. Smaller stars, when they die, turn into something many refer to as neutron stars, extremely dense but not dense enough to trap light. However, if a star is multiple times the mass of our Sun, it collapses under its own gravitational pull, forming a black hole. As these powerful stars collapse, something strange happens near their surfaces. Time itself starts to play tricks. From the perspective of an observer far away, time seems to slow down near the event horizon, the point of no return for anything that falls into a black hole. It's as if the star's clock ticks at a different speed compared to our own. Sometimes, when two smaller black holes collide, they merge to form an even bigger and more terrifying black hole. If a black hole interacts with a neutron star, they create a monstrous nightmare that defies comprehension. Researchers have long wrestled with the size of these vast phenomena. Black holes generally come in two sizes, gigantic and small. But small is relative when it comes to black holes. Supermassive black holes, the remnants of giant stars, can be as massive as 10 to 100 times the size of the Sun. There could be upwards of 10 million to a billion of them in the Milky Way alone. That's a galactic number of black holes, each capable of swallowing anything that stands in its way. But wait, there's something even more monstrous. Supermassive black holes sit at the opposite end of the spectrum, being millions, if not billions, of times more massive than the Sun. They exist at the centers of large galaxies, including our own Milky Way. It's like a vast, dark emptiness pulling everything toward it. Famous physicist Stephen Hawking spoke extensively about black holes throughout his life. His lectures were always insightful, though some of his theories were impossible to confirm due to the lack of necessary equipment. However, there is hope on the horizon. A single scientific instrument is changing everything, and we may not be ready for it. It goes by the name of the James Webb Space Telescope, JWST, and it's here to take us deeper into the mysteries of our universe. The JWST is not just a typical telescope, it's an engineering marvel, a testament to human ambition. Sure, we've launched other space telescopes before, and they've done their jobs just fine. But this one? This is on a whole other level. The JWST makes the Hubble Space Telescope, which has faithfully served us for decades, look like a mere speck in the vast universe. And the price tag for this galactic miracle? A staggering $10 billion. Yes, you heard that right, that's enough zeros to make your head spin. And get this, it took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency, along with contributions from over 300 universities, to bring this wonder to life. But let's not forget the risks that come with such a grand endeavor. This is not a project for the faint-hearted. The JWST is venturing into uncharted territory, pushing the limits of what we know, and taking us to places we've only dreamed of. Following a successful launch, NASA recently announced that the telescope has enough fuel to last more than twice its original mission lifespan. Since its launch, the JWST has made many incredible discoveries, traveling over one. Since its launch, the JWST has made many incredible achievements, traveling over 1.5 million kilometers away from Earth to its designated position at the Lagrange point 2, L2. From this vantage point, it has begun capturing breathtaking images of the universe, revealing never-before-seen details about galaxies, exoplanets, and cosmic phenomena. One of its most groundbreaking discoveries came when it detected ancient galaxies that formed shortly after the Big Bang. These galaxies appear much older and more structured than scientists previously thought possible, challenging our understanding of how the universe evolved. But the real shock came when JWST captured data that suggests we might be living inside a black hole. This mind-bending theory, which has intrigued physicists for years, proposes that our entire universe could be the interior of a massive black hole existing within a higher dimensional space. The JWST's deep space observations have provided new evidence supporting this idea, as its infrared sensors detect distortions in the fabric of spacetime, phenomena that align with the predictions of black hole cosmology. Could we really be inside a black hole? To understand this theory, we need to dive into some mind-bending physics. According to general relativity, black holes form when massive stars collapse under their own gravity, creating a singularity, a point of infinite density, surrounded by an event horizon, the boundary beyond which nothing can escape. But what if, instead of collapsing to a singularity, a black hole formed a new universe inside it? Some physicists speculate that when matter falls into a black hole, it doesn't just get crushed into oblivion. Instead, it could emerge in a new region of spacetime, effectively creating a baby universe. From the outside, we see a black hole, but from the inside, it might look just like our own expanding universe. JWST's observations of cosmic background radiation, the distribution of galaxies, and the unusual behavior of dark matter suggest that our universe behaves in ways that resemble the interior of a black hole. What this means for our understanding of reality. If this theory is correct, it would completely reshape our understanding of the universe. It could mean that black holes are not just cosmic endpoints but bridges to new universes, a concept that aligns with some interpretations of quantum mechanics and the multiverse theory. Moreover, if our universe is inside a black hole, then our own black holes could potentially contain other universes within them. In other words, every black hole in our universe might be a gateway to another reality. This idea raises profound questions. Is there an outside to our universe? If we are inside a black hole, what exists beyond our cosmic event horizon? Could advanced civilizations one day escape our universe and enter a higher dimension? The future of space exploration. While the idea of living inside a black hole is still a theoretical possibility, the James Webb Space Telescope is giving us more clues than ever before. As it continues to peer deeper into the cosmos, we may soon find definitive evidence that challenges the very nature of space, time, and reality itself. For now, all we can do is keep looking up, because with every new discovery, we are one step closer to uncovering the ultimate truth about our place in the universe. Million miles to reach its orbit. The James Webb Space Telescope traveled millions of miles to reach its orbit around the Sun, where it will remain forever. During its journey, the telescope successfully unfurled its massive 5-layer sunshield and large primary mirror, both of which had to be folded to fit. Moving on to the launch vehicle, now that NASA has calibrated and adjusted it, the telescope is nearly ready for full operation. One of the most interesting aspects of the James Webb Space Telescope was when NASA announced it had captured its initial images of starlight. The first image taken by the telescope was of a star called HD 8446, resulting in a mosaic of 18 scattered stars with bright spots, light captured by the 18 mirror segments on the primary mirror. NASA later released another, better-than-ever HD quality image of HD 8446, where the 18 copies of the star were combined into a deliberate hexagonal arrangement. Once the observatory successfully aligns the individual segments of the primary mirror, it will begin the image stacking process, bringing the 18 images on top of one another for a clear view. As a result of its advanced technology, the JWST will help scientists examine the early stages of the universe after the Big Bang. It will study what happened after the first stars formed, a period known as the epoch of reionization. This era refers to when neutral hydrogen was reionized, made to have an electric charge again, by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also assist scientists in finding exoplanets, which are very hard to detect due to the way they interact with their host stars. Its powerful sensors will be able to observe these planets in more depth, including, in some cases, imaging their atmospheres. A deeper comprehension of atmospheres and planetary conditions could help scientists better predict whether certain planets are habitable or not. In addition to investigating the formation of worlds, researchers are studying galaxies to comprehend the organization of matter on a massive scale. This, in turn, allows us to see how the universe evolved. The galaxies that are elliptical and spiral today evolved from different shapes over billions of years. One of the JWST's goals is to look back at the earliest galaxies to better understand that evolution. Scientists are also attempting to determine how we came to have the variety of galaxies visible today and how galaxies currently form and gather. The biggest question of all. However, most importantly, the James Webb Space Telescope will help us answer the biggest question of all. Are we alone in the universe? And an even deeper mystery. Are we living inside a black hole? The JWST has already begun the search. And guess what it found? Compounds called polycyclic aromatic hydrocarbons, PAHs, lurking around huge supermassive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures are like the goth children of the universe, found everywhere, from distant galaxies to comets in our solar system. But they're not just fascinating because they could be the building blocks of life. They also assist astronomers in locating star formation. When ultraviolet radiation hits these PAHs, they glow, producing a signal that can be detected by mid-infrared light. The JWST's mid-infrared instrument, MIRI, picks up this signal, which typically indicates the presence of hot, young stars. The shocking discovery. But here's the twist. A daring astrophysicist, Ismail Garcia Bernard of the University of Oxford, decided to take a closer look at 3 active galaxies. NGC 6552, NGC 70319, NGC 7469, part of the famous Stephan's Quintet. These galaxies, located millions of light-years away, hold a terrifying secret. What Garcia Bernard found in the central regions where the black holes rule will make your hair stand on end. He discovered an abundance of PAHs. Sounds great, right? Well, here's where it gets chilling. The intense radiation near these supermassive black holes warped the very essence of the PAHs, transforming them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs? They disappeared into oblivion. Imagine being consumed by darkness itself. The ultimate question. However, there's a flicker of hope, or perhaps, something far more disturbing. The ultimate question here is not just whether we're alive. It's whether we truly exist at all. Could it be that everything around us exists because of the black hole we are in? It all ties into a controversial theory. Perhaps, we're not simply living inside a black hole, but rather, we are at the border of the event horizon, a threshold between the universe we think we know and the unknown. Could it be that everything is connected within a black hole itself? The James Webb Space Telescope is currently searching for answers to the unknown. Stay tuned. Because maybe, just maybe, it will make us rethink everything we thought we knew about existence. The truth may be far more twisted than we ever realized. A universe of questions. If the James Webb Space Telescope is truly capable of peering billions of years into the past, then what happens when it reaches the limit? What if, at the very edge of the observable universe, we see something impossible? Imagine looking back so far that we witness the birth of not just galaxies, but the very fabric of reality itself. If the universe was once a singularity, a single point of infinite density before the Big Bang, then what lies beyond it? Is there a before the beginning? And if we're inside a black hole, does that mean our universe has an exit, a point where everything we know could collapse into something else? The JWST's instruments are powerful enough to detect light from the first stars. But what if, beyond those ancient stars, there is only nothingness? The black hole hypothesis. Physicists have long speculated that black holes might be gateways to other realities. When matter falls into a black hole, it doesn't just vanish, it collapses to a singularity, just like the very eyes starting point of our own universe. Some scientists suggest that every black hole might birth a new universe inside it. If that's true, then the black hole at the center of our own Milky Way, Sagittarius A*, could be the umbilical cord to another reality. If we could somehow send a probe past the event horizon, would it be destroyed? Or would it emerge somewhere else, in another universe? Perhaps, in some distant galaxy, an advanced civilization has already tried. The cosmic horror of reality. But here's where the mystery takes a darker turn. If black holes create new universes, then what created ours? What if our universe wasn't the result of a cosmic explosion, but a cosmic collapse? A black hole in some other universe, feeding the birth of ours? And if that's true, then what happens when our universe reaches its end? Will it, too, collapse into a new black hole, birthing another reality? Or are we doomed to be swallowed by the darkness, erased like the past near supermassive black holes, consumed by a force we can barely comprehend? The James Webb's mission. For now, the James Webb Space Telescope continues its mission, searching for the first light of the universe. But along the way, it may find something we're not prepared for, something that shatters our understanding of existence itself.